Hello, hello, and welcome to this video. This video is a continuation on the traits. So we will revisit our last example, and I hope that you remember that we needed to perform type annotation for here sheep, which implements the trait animal. Now we could have another animal like cow, which can implement the animal trait. Okay. So this type annotation is necessary so that Rust knows that which animal it is going to create the object for. So this is called static dispatch. Okay. The size of this dolly will be known at compile time. It will know exactly that which talk to invoke, whether the talk of cow or sheep, whether shear is being performed on cow or sheep. This is known at compile time. So this is very fast. The downside is that you have to implement all those traits all the time. Okay. Now, one of the techniques which we do in object-oriented programming is called dynamic dispatch. The way to perform a dynamic dispatch is with trait object, din trait object. Okay, the word din is essentially dynamic. So what this means is when you use a din trait, it tells the compiler this value implements this trait, but its concrete type is unknown at compile time. Use a vtable at runtime. So what is a vtable? Vtable, the full form is virtual table. Since C++ is more popular, I'll give you a C++ example. Okay. So suppose that we have a base class. For example, it could be shape, and it has a pure virtual function called area. Now there are two concrete classes which derive from this base class, circle and square, and both implement this function area. Now we create an object of circle, let's say, and assign it to the base class pointer shape. So when you invoke the area method, then there is a table for each concrete class, and that table will point to the actual function. The pointer will be there, a function pointer which will point to the area function of each concrete class. And by that doing at runtime, that which object it is, it goes to that vtable and invoke the function. Okay. In static dispatch, you don't need this vtable at all. Okay. Now that's what dynamic dispatch is. In Rust, we can do static dispatch using generics or impl trait. We have not yet studied generics, but we will see it eventually. The benefits of static dispatch is the fact that it is fast and it has no indirection. Another benefit is that the functions can be inlined by the compiler. In dynamic dispatch, it cannot be inlined. So there is of course a bit of performance loss for dynamic dispatch, although it is negligible. But the advantage of din trait is that it is quite flexible. Okay. So for when should we use din trait? So din trait is used when we need a heterogeneous collection. We want runtime polymorphism. The set of types is not known at compile time. So now you would ask, how do we not know this at compile time? We'll see that soon enough. So first we will see two examples. One of them is this. And before actually going to the example, let's look what the standard library says. Din is a prefix of a trait object's type. The din keyword is used to highlight that calls to methods on the associated trait are dynamically dispatched. This is a Wikipedia link. You should go and read it here. It's in all the glory, C++ examples and all that, C Sharp, Java, Python, Rust, everything is there. So you can read this. In fact, we can look at the Rust example. I have not planned, I have not seen it, but okay. So we have trait pet, which has a function speak. So you can consider that as an abstract class or interface, and this is a virtual function. Now we can treat that dog basically implements this pet function. Okay, here. All right, it implements the pet function. You can assume that dog derives from pet and overloads the virtual function speak and says woof. Similarly for cat, it says meow meow. Okay, and then here you receive a dinpet, that is you receive a base class pointer, and this is the variable, and then you invoke method speak on that base class pointer, in this case our din trait. Now at runtime we have dog from dog named Fido and a cat named Simba. Now we invoke speak, we pass Fido and Simba. So you see over here, Fido is a dog, we know that. Simba is the cat, we know that. But this function does not know which object it is going to receive. It can receive a cat and it can receive a dog. Both are two different concrete types, but it can accept both of them. That is, this is also something to keep in mind, like Liskov substitution of solid, L of solid. So what Liskov says that the base class should be able to substitute the parent class. So this is the, sorry, parent class, base and parent are meshed. The child class should be able to replace the parent class. So this child class is replacing the parent class over here. So that's how you do dynamic dispatch in Rust. Now let's go back to documentation. To use the trait this way, it must be DIN compatible. Unlike generic parameters for simple trait, the compiler does not know the concrete type that is being passed, that is, the type has been erased. So this is the type eraser link, you can go ahead and read it. As such, a DIN trait reference contains two pointers. One pointer goes to the data, that is an instance of a struct. Another pointer goes to a map of method call names to function pointers, known as virtual method table or vtable. At runtime, when a method needs to be called on the DIN trait, the vtable is consulted to get the function pointer, and then that function pointer is called. See the reference for more information on trait objects and DIN compatibility. So you can go ahead and read this. This is the reference of the language. We will not go and read this. This can be quite involving, at least for the beginners. So the trade-off is that the compiler cannot inline that, and DIN trait will produce smaller code than impl trait or generic parameters, as method won't be duplicated for each concrete type. Now let's go back to our example. Okay, so we have two concrete structures, sheep and cow, and we have a trait animal which has one method, noise, which returns a static string. Now we implement it for sheep, animal trait for sheep, and in the noise method we say ba. For cow we say moo. And we have a random animal which receives a random number, and if random number is less than half, it returns a sheep. Now it wraps in a box. Okay, why it is wrapped in a box? There is a reason. Whenever you return a DIN trait object, that is like DIN animal here, the object of this, the size of this object is not known at compile time. Okay, so it must be a pointer. When it becomes a pointer, the size of pointer is always known. It would be 8 bytes on 64-bit systems or 4 bytes on 32-bit systems. So basically, let me give you a classic example. In C, you cannot create a variable of type void because the size of void is not known. But you can create a void pointer because the size of void pointer is always known. So think like that. Okay. The size of din animal is not known, but the size of the pointer is known. So I was saying that if random number is 0.5, then return a pointer of sheep object, otherwise return a pointer of cow object. Now we have a random number hard coded. So you can argue that we know the random number. Why don't we invoke the static dispatch in this case? Okay, there is a problem. Okay, the problem is the random number can be generated at runtime, and then you actually don't know at compile time. I could use a random function to generate this random number, and then there would be no way to know it at compile time. This is just an example of hard coding. So now we call random animal and pass the random number. Now see, the type annotation is not needed. Animal will be known at runtime. We don't care what animal it is. We just invoke the function of the trait. That is noise. Okay, let's run this. Okay, cargo run. Go run. Okay, so you randomly chose an animal. It says ba. Let's see if it prints moo at any time. Ba again. Ba. Ba. Okay, I don't know how many attempts we need. Okay, no moo. Oh, sorry, it is hard coded. This this is hard coded. Let's make it one. So silly me. Okay, terminals. New terminal day one. We don't need this. We have the terminal. Cargo run. Now it is more. Okay. I made the mistake of ignoring the hard coding. So now one of the things we see that we can return a trait object wrapped in a box from a function. The other usage of this trait object is that it can be received as an argument in a function. We'll see that example quickly and then we'll wrap this video. So consider I was talking about the shape example. So here shape, we have area. We have two struct, circle and square. Both are constructed using radius and side. So suppose we have shape for circle, we say area is equal to pi r square. That is pi into radius. And we have area for the square shape. It returns side into side. And both return f64. Okay, this is important, huh? Because we are going to invoke area. So this f64 should match the shape return type. Otherwise the impl won't work. Now we have a function print area which receives a reference of dynamic shape. Okay. Now what we do is we create a circle, we create a square, and in print area we pass the circle and shapes references. Okay. If you don't pass the reference, it won't work. Most probably it won't work. Let's remove this. You see the problem. So cannot be known at compile time. So we send a reference which is essentially the address. So once we have this, we pass the reference of the object. It will invoke area on the shape and give us that. So let's run this and then we will cargo run. So we have the area of the circle and area of the side. So that's how you do dynamic dispatch in Rust. That's how we write flexible code. One of the examples of traits would be writing plugins. Okay, you need traits to write plugins. I'm not talking about din traits specifically. I'm saying about traits in general. Now another example, you can think of it this way. Suppose we need a logger. The logger could write to what you call a file or to terminal or console. So we can have two what you call classes. One could be console logger, one could be file logger. File logger could receive a file descriptor from the main function, open file handler, and then in the impl we can say this area could be a log line. We receive a string for this, and we return nothing. Okay. Now in that case, the constructor would construct the objects. Okay, and the log line function, which will receive a string, would either print to the what you call console, and in case of file logger, it would write to the file descriptor, that is to a file, open file. Okay, and then you can invoke this function log with the this way, or you could do this way. You simply use logger.logline. Okay, once you create the logger, you can create the logger based on, say, some configuration file option or a command line argument. And once you create the function, we invoke the log line on the dynamic object. So that could be another example. So we have seen all in all 4 examples, one from Wikipedia and 2 we have shown, and 1 we talked about. So with this, I'll stop here, and I hope that you have found this video useful and informative. So if so, then please subscribe if you're not subscribed, like the video, share it on social media to your accounts, and if you have questions or you want videos on certain topics, let me know in comments. I always try to reply to comments if there is a question at least. If it's not a question, then I may not reply. But if it's a question or you want to discuss something or you need some other help, I am here to help you. The reason why I ask for like and sharing is that it helps to see good stat in analytics. Basically, the more stats I see, the more motivation is there. You feel happy, you get dopamine. So it's kind of selfish. But the other side effect of sharing would be that other people who need to understand basics of Rust will be able to possibly come to this video and get benefit. So be a good citizen, or Samaritan is the word, right? And help everyone. So thanks a lot for watching. Happy programming.